part of the operating system. Okay. Are you recording yet? No.
Hey, I'll be right back.
Oh, nice.
This will be brief because I didn't even finish.
I can,
What?
I can cut it
Okay.
and then somehow transition that to AI.
So we're live? Okay. So this is probably the first programming talk I've given. And is it our first in the club?
Yeah.
Yeah. That's cool. We don't talk a lot about programming because we don't want people to think that this is a programming club. Because that's a negative stigma that seems to come with just being a gaming club. But object-oriented programming. If you're in CS, I highly recommend taking the class on object-oriented programming as soon as possible, just because it's what will teach you how to. I said this the other week that it will teach you how to deal with large programming projects, working in teams, but also just dealing with all the complexities of working in a very large program. So here's regular programming, which big emphasis on the quotes because that's probably not the name that people like to give it. But if you don't know anything about programming, it's just a series of statements, and each statement does something. And it just reads them down the page and it executes them, and it's very easy. When you start making large programs that do a lot, it gets out of hand very easily. So one cool trick that people use is they split it into functions. This makes the program much more readable. You break it up into smaller sections, and it also really helps a lot with collaboration. If say you're writing one section of a program, you could plan it out ahead of time and say, we're going to have these functions. You can write these functions while I write these, and they'll work seamlessly together. But then, as you keep making larger and larger programs, these things just start getting out of hand. Eventually, you need to break things up into multiple files. And if you don't have any, if you're still working with regular programming, you're going to be really tempted to just step all over each other. Like say these two files are being written by two different users. The first user wrote this one file, and now the second user is writing it, and the second user is trying to figure out how to write the code that he wrote. And so he was like, oh look, there's a function that I want to use. I'm gonna just bring it into my code. I'm just gonna call it up. And the problem is that the original programmer did not intend that to be used. And then eventually they just keep bringing stuff in and making all these unplanned dependencies among each other. And it's terrible. And then the next thing you know, the other guy starts to do it too. And then what happens when you need to change something? There's a bug in the code, or you want to add functionality. And then the first programmer, he changes his code, and then all of a sudden this doesn't work anymore. And everything breaks, everything dies, and it's bad. So even if you had clearly documented all of the dependencies that you were using, just the idea of being so reckless that you can just jump all over each other like that, get the programs entangled so badly, it's a nightmare. And then what if you have dozens of files in your program? Because programs really do get big really fast, especially if you're building something on a very large scale. Like a game would take a lot of time. Yeah. Imagine even if you did all the best planning in the world, all these files were dependent on each other as planned, and everything's working okay. But now you want to change something, and say there's an algorithm in file 5 that needs to be updated, and you're considering can't change it this way because that's going to break this file, and I can't change it this way because it's going to break that one, and it's gonna break that one, and it's just horrible. It's way too much.
By a mutant spider.
Yes.
That's all that.
you get it's way too many things to consider. That's not nice programming. So it's in order to deal with this complexity, you need to set up a system of abstraction. Computer science is all about abstraction. That's how you solve complexity. This is a really upscaled image. It was much smaller than this, and I stretched it out. It was from one of the books that was assigned when I took the object-oriented programming class. Basically, to make things simple, all you have to do is make the illusion that it's simple. It might be a big mess inside, but as long as it's clean on the outside, then it's usable, and it can make working with that program all the more easier. So the first problem that we need to solve in the previous case, the spider, the way we're organizing our code is really arbitrary. We're organizing things on files just based on, okay, this might be related to each other, or this has to do with, this is something that this guy wrote, or this is all this stuff that has to do with input and output or something. It can get arbitrary at times, and there's no real structure to do it. So came up, a better way to organize the code would be through objects. Oh, I guess it doesn't come up yet. But, so what we do, we take all the data, which is basically variables, pointers, arrays, etc. And we take all the code that uses the data, and we wrap it up into something called an object. The idea of putting things in objects, it's not a file anymore. It's not just a bunch of code that's on a page that you can start messing around with. The whole point of calling it an object is to encourage you to think about it as an actual thing that you interact with. You're not supposed to break it apart because then it's not an object anymore. Before I move on, the whole idea of functions, this is another thing of abstraction. We abstract all of the code into functions. You cannot have code unless it's in a function. And that's a really cool restriction because it forces you to be modular. So here's a basic structure of an object. You have data and code or functions. And you have two categories, either public or private. The private data and the private code is almost like it's in a black box. No one can see it, no one cares about it, no one should care about it. All they care about is the public interface of it. Interface. This is the interface of the object. It's how all the other objects in the program interact with this section of code. You're not allowed, and you're not supposed to, and you're definitely not allowed to care about how the actual program implemented itself. Which means you can't say, like, oh, they're using this routine that I want to use, so I'm going to call it up and point it to whatever I'm manipulating. You just can't do that. If you really wanted that, you at least just copy paste the code and put it in your files. It's just cleaner. Less dependencies. So this is how it looks like from the outside. You see, there's no idea of the hidden elements. It's much more cleaner and a lot easier to deal with. There's less things to consider when you're going to use this class. All you really have to consider is, okay, what is the data that it has, or if you're using functions, what are the inputs and the outputs in the functions? And you couldn't care less about how it actually does it, unless it's like in the documentation, it's like, this is really slow, or this is really fast. But other than that, you're not supposed to worry about it. And that's the beauty of object-oriented programming, because it really forces you to simplify everything. If you had to, like, say, if everyone's in the CS department, if you work with Java, so much easier just using the Java API classes, like array list or linked list. You don't, whenever you call up a function from an array list object, you don't have to sit there and think, okay, it's gonna run this code and then that code and then that code. No, all you care about is the end result, and it's super easy. Interfaces are very strictly enforced in object-oriented programming. Like if this object is using this function, that's okay, as long as it's within the right scope. But if it tries using anything in there, then the program won't even compile. And that's about the most enforcement you can get, just compile error. It won't even let you run it. Like if you run in C, if you programmed in C, C lets you do a lot of crazy things. The compiler only cares about like syntax, as far as I know. If you can try running it, even with warnings, and just see what happens, and you can really mess stuff up. But object-oriented programming languages they're much stricter, and it's like that for a reason. It's for your own good. And that's why high-level programming languages, the kind of languages that have a lot of abstraction behind them, that's why they're usually the best languages to work with when you're writing these really huge programs. Like I know the first time I heard of Python, the website said NASA uses Python, and like, well, that makes sense because NASA makes these really, really complicated programs, just software to run all of their systems. So you would want a high-level language to deal with all the complexities, to hide the complexities away. So that's where my PowerPoint ends. But I feel like I should show some code because, okay, let's run Eclipse. I don't know why it didn't have it open. I thought I opened it. That's Flash filter.
Right.
But it's fake. It's a fake Adobe product. It's actually Eclipse.
Why? What?
It's true.
Did you change this?
Why? What would you do?
Eclipse help.
Yeah, what?
But at least it has Flash mode, which is cool. So I wish I picked out a good program before. I wish my monitor was better, so that I didn't have to turn around.
What did you do for the final project?
I know, I showed Flash. Final project 335. I did a.
You did the honors one, right?
I did this. This is.
That thing.
No, it wasn't this. It was this one.
But like, they kind of, I don't know, we were confused because Java already kind of has a spreadsheet, and so we were like, why did you make that? But, I don't know, I guess you added like functions to it and stuff.
So,
apparatus. Snodgrass.
So I didn't even talk about classes. Classes are what define objects, or at least in Java. So a class is basically a specification for an object. You specify what its data elements are. And objects are only instances of classes.
A blueprint.
The class is a blueprint. And each file is a class, which is a much better way to organize code. Or not, you could put more private classes. So here's the point of entry in the program. Main. And you see what it does? It creates itself. That's what it does. And then you go to where's the constructor? It's not even here. It's the bottom. I don't remember if I'm the one who wrote this class.
No, it's Jane.
Wait, I know. This is cool. I can just click on it. What? There is no constructor? I it probably goes to the super constructor. No, that's not how Java works.
Yeah, the why? No, doesn't make sense though.
Maybe
It's really weird. Whatever.
Who cares?
Well, you don't need a constructor.
I don't think we did use one. Yeah, that's, you just have a start. That's not good.
Yeah.
Anything. Whatever. Anyway.
I need another object.
Specifically doesn't have a constructor.
Yeah.
What they're doing, what design pattern specifically doesn't have a constructor.
Well, it doesn't have a public constructor.
Yeah, public constructor.
Singleton.
Single.
It has a constructor.
This is another
It's just
file.
private.
Constructor.
Yeah.
It's static.
Okay. Maybe I shouldn't show this advanced code. These
Yeah,
are
probably not.
implements.
I think the abstraction is pretty much
Yeah.
what's important.
Abstract class implements.
So
Right.
what I want to show is how you interact with objects. This is an object, right? This is a class. No, this one.
It's an object.
Yeah, this is an object.
That's a singleton.
It's a settings object. And so in most programming languages, you just do dot, and then either you get there. That's Eclipse list of help stuff. This is a variable. You can tell by because it doesn't have the parentheses around it. The rest of the stuff are functions, which you call. And you see there's documentation on it, which tells you what it does, and that's why you should comment your code.
Now we know.
Now you'll never forget to comment again, just because I said it.
I think McCann is secretly pulling your string.
Okay, I think that's enough.
Yeah, I know. I think he's got like a microphone. He's like walking.
So yeah, this is the end of my presentation. Just kind of stops with no conclusion. Well, the conclusion is that you should comment your code.
And there's copy paste.
Yeah.
Is there a great issue?
Maybe you could make a metaphorical example of object-oriented, well, object-oriented.
I have a
You
feeling.
can abstract any system into.
Take this
Yeah.
microphone. You interact with it by pushing the buttons on it, but you couldn't care less about the actual electrical engineering that goes behind inside the system.
I actually care very deeply about that.
Not when you're trying to use it. if you're trying to use it, you just want to know, will it work? And unless you're trying to break it apart, then it becomes relevant. But yeah, that's just how human minds work. They abstract everything into some kind of, I don't know if it's accurate to say that we abstract everything into an object, but just abstracting things so that instead of dealing with all these different variables about a system, we can just call the system one variable and say, that's one thing. It's not a bajillion things. So yeah, it's good to, when you're designing your programs, to remember that. People that, especially if you're on a team, if you're programming a class, remember that other people are going to be using that class. So the interface for that class, for that object, should be easy to use and intuitive. You should not make a function called add that really deletes stuff. That's not intuitive. And you shouldn't make functions that do too much either, because that's not intuitive either. Like, especially if the things that they do are irrelevant or very specific to implementation. Like, oh, this function is for this one time, even though it looks like it's supposed to be used in a general case. That's just bad interface design. Yeah, most programmers don't even think about interface design. That's what they should. Because then the world will be a better place. Is that a question?
Not functions or methods.
Yeah, but
Functions return the same thing given certain input every time. That's what the
yeah, and
function
you could also get confused by the mathematical definition of function if you come from a math background.
is. Or if you use those other programming languages.
Yeah, functional programming. So Dylan, are you coming up now?
Sure.
I'll set it to the workstation.
I could probably extend that thing a little better. Yeah, so apparently if you look up foot skating in video games, it's just a bunch of people like wearing those like Heelys and skating around on stuff. I don't know. Don't care. So, but I was gonna say, like, you can extend, so he said like a microphone and it represents all of this complex stuff inside of it. But usually the reason you have an object is because like it represents some kind of functionality. Just like a specific responsibility. So if you were like decomposing a computer into objects, you might have like your graphics hub that deals with putting out stuff to the monitor and like doing all the floating point calculations you need in like 3D animations. And then you have your normal processor, which does like everything else and kind of like manages the rest of your stuff. And then you have your hard disk, which it like accesses and gives you memory. And your hard disk does that one thing. It just keeps track of that memory and that kind of stuff. But yeah.
Unix has a really cool system where they abstract almost anything as a file.
A lot of stuff does that, but yeah. So it's kind of hard to find an example given that I just showed you that Google failure. It doesn't even matter if you can hear it. So what I'm kind of pointing out here is when just really pay attention to like people when they're walking.
If you're talking, you can probably look up like third person Elder Scrolls Oblivion animations or something, and it's what I think.
Right.
It is. They do it a ton.
But I'm just talking about that kind of thing. So like they're turning on an axis that isn't realistic. So like whenever you see a video game and somebody's just like like that. So that's the kind of thing that is an inherent problem like between AI and animation. But I really didn't need this. This was just kind of like a do. So I guess to start out with like AI in general. Some AI, like it starts out extremely basically, like surprisingly basically. So I have notes here. There we go. So kinds of agents, huh?
I said somebody's prepared.
No, this is from a class.
Oh.
That I just happened to have on me. So, right. Okay, so there's like 5 basic kind of agents that you kind of pay attention to when creating AI. And the agent is just like the way it goes about thinking about the world, the way it chooses actions, makes decisions, that kind of stuff. So the first one is a table-based agent. And that is literally just, it has a table of something. And every single time you tell it to do something, it's like, oh, you told me to do X. Well, let's look up X in the table. You also told me to do Y. And I'm going to do this. And it just looks everything up. Everything is predetermined. It just finds out what it wants to do from a table. But you can imagine, in a video game, consider the fact that you're not on just like a square. You're on like a floating point number somewhere in a gigantic map. That table is going to be humongous. There's no way.
Will it be a 3-dimensional table?
Don't even know.
Eight-dimensional table.
Just that kind of table is going to be gigantic. And that's even abstracting it further. So this is assuming that we only care where they are. They're only going to make a decision based on where they're standing, not who's around them, not all of this stuff. So there's going to be tons of variables. And it's going to be like a 50 billion dimensional table that expands the entire map, which is huge. And there's no way you're going to include that on anything. Like, you're not going to give that to someone in a game because that will be like 50 billion DVDs. So you kind of, this is a progression towards like complexity versus like the amount of space required to store that kind of stuff. So in the table, you're storing every single possibility. Then with a reflex agent, you're basically doing it based on like these rules you have. So you just have like a list of rules. So just like And these kind of abstract that because each one of these, like, there might be one rule that governs a bunch of these kind of things. So it's like if Y and X are this kind of thing, then that's that rule and that's what we do. So it kind of brings the table into a little more condensed thing. Then we have memory agents, which actually act in the world and they do things based on experience. So like how their previous encounters have gone. So like if they do something and they die, they'll know that they probably shouldn't do that again. If they ever get into that exact same situation, they'll be like, nope, other way. So then we get to goal. So a goal is, so these are just kind of like things telling you what to do in specific spots. A goal is when you have like something there that you're actually trying to get to, and you look at each of your actions with respect to that goal. So you say, will this get me closer to my goal? Or will this get me closer to my goal? And I'll choose the one that does it better. And then utility is the final one, which is you have a bunch of goals and you measure like the utility of each goal. So like you'll have actions that say, yeah, I want to get to this goal or this goal, but you also want to know like which action you want to take towards each goal. So I don't want to use that grid then, but and that's just so you're here, you want to get here or something like that. And you have like a cost for living, or you want to get here too. Yeah, I guess that would be it. But the game doesn't stop when you stand on one of those, you just have to like activate it or something. So your goal-based agent might look at this and say, okay, well, I can go here to get to that one, or I can go here to get to that one. So there are multiple goals, and it can go like that or like that to get to that one. But you know that like this is the shortest path, like it'll only take 3 steps to get to this one. But even though it knows which one to go to, it still has to decide, does it want to go this way or does it want to go all the way around this way? And there might be something here that's horrible that'll kill you, that'll make you choose this way to get around. And then you would consider this goal might be a little better. But that's just kind of like a way of abstracting it so that you don't have to keep all of this data, and it really saves you a lot of time. So that's just kind of getting into the general thing of AI. So with, where did I put it? With animation, with respect to that, what you really need to be able to do is kind of predict what's going to be happening. So like, instead of just knowing where you're going to be in one turn, you want to know where you're eventually heading up or something like that. So you know, yeah, I'm moving to this spot, but I'm gonna keep moving towards that. And really, when you consider like that foot skating thing, if the AI just like immediately decides to turn, the animation kind of can't really flow into that. There's like nothing to do there. So the animation, like one of the big parts of it is loading up all of those models for your dude who's trying to turn. And so if the animation doesn't know you're about to be turning, if it hasn't been preparing for that, it might not have those models loaded up. It might not have like all the data it needs at that time, and it'll be really slow and laggy. Like it'll just like skip or something when it's loading all of that information. So yeah, that's sort of a really big problem with that. And okay. And so another thing is that really what we've been kind of come to expect in games is that we want it to look realistic-ish. So we want the actions, instead of just like hopping and turning like immediately, you just want to kind of like turn like that, and you want to see the foot pivot and like the legs move smoothly. But the problem with that is they can't animate every single possible like thing that could possibly happen. So really, all they can kind of do is animate some of them, and then they have like a bin of animations they can pull from. So when the AI makes its decisions, it doesn't say like which animation, it doesn't say like which move is the best necessarily. It has to consider that move with respect to like, and then this one is like, I don't know. Anyway, something's happening there. So this move, the animation for it takes 4 seconds. The animation for this move only takes 3 seconds. And there are certain chunks that you can't just split off into because then the animation will look really choppy. Like you'll be halfway through something and then you'll be doing something completely differently. Like it's like split second. So they have like little bits of animation that flow smoothly into each other that when you're at this bit, you might want to like turn around and go to like this one, or you might want to turn to go to this one. And this itself is like, yeah, its own little animation bit. So this mostly matters in like 3D games, because in 2D games you can kind of fake a lot of that stuff and it's not that big a deal, but in 3D games you can definitely tell if like a physical 3D object just kind of skips somewhere, as opposed to just like a sprite just kind of like moving, because sprites are kind of like jittery anyway, so you might not notice as much, but in 3D games you definitely would. So this animation could go into one of those animations. Like based on this, you don't know necessarily which one it's going to go into, and that's really helpful because you can just like, you can go into this one and then you have multiple options, and you're prepared for like more events. But that's kind of the best that they can do at that point. So what it really helps if, because of this AI, it tells you you're going this way. So it loads up this animation instead of this one. And so now that it's loaded that up, because it knows you're probably going that way, when you do go that way, it already has that stuff ready and it doesn't lag to render it, it just puts it up, because you're good. And, right. So the AI also cares about the animation, because if, say you like wrote an AI for a system and it was all working perfectly, and then the animators changed something, and they made this animation crazy and detailed and insane, but now it takes 2 seconds instead of 1. But this guy is going to be pretending like that only takes 1 second, because that's how your AI is looking at it. And so it's going to choose that option, and your AI is going to be like behind, so it's going to do something extremely stupid, like run out into the middle of an open battlefield because the animation was extended and your AI didn't know about it. So that's really the problem that comes up, is the AI needs to know which animation like is better, and the animation needs to know where the AI is going to go so it knows which one to load up. And then there's sort of a solution to that. I don't know. I read something about someone talking about solutions. So one of the solutions was to use a goal-directed system, like I was talking about. You have a goal and you're going towards it, so you can predict kind of where it's going. So the animation knows which one to choose. And so it's not that great to integrate them too heavily, but it really helps to like have at some very low level your animation aware of your AI's actions and your AI aware of your animation. Like normally with like object-oriented programming, you'd have some kind of object that governs a specific like section of your game or a specific responsibility, but you might want to have like even though they might not look like they should, you might at some point want them to kind of like look at each other and say, okay, yeah. And it can help a lot if you design your system like starting with that in mind, instead of just having them completely separate and then tack on random like additional considerations in the middle, which is not very helpful from a programming standpoint. Yeah, and then I guess the last thing that would help is to, I mean, this is talking about game development, and this is a 3D game, so it's going to be a gigantic team of people. So it really helps if you have a team that's not just dedicated to AI or animation, but that's dedicated to both. So like, And it's not necessarily that. So you won't necessarily have a team that's just this without those. You'll probably have all three, but you need some way for the AI people to be able to constantly be in communication with the animation people so that they don't change something that screws the animations up, or so the animations don't screw something the AI was not planning on. But yeah, I think that's about it, unless you want more about AI and less about animation.
That was really cool.
Do a dance.
Okay, so are we doing
For
that?
entertainment.
That
What are we doing now?
discussion thing? I can talk more about AI. Or we can do that discussion thing
anything
that
else?
Christian was discussing. Yes, of course.
Of course.
That you know I don't know anything about.
But we can do that thing, like, were you suggesting,
Group game analysis.
yeah,
Something, a solution to that would be to talk about one game that everyone supposedly has played. What
Right.
that was about.
is there any game that everyone has played?
Unlikely.
So,
Any of the Mario Bros.
we were not played any Mario games.
Pong. Pac-Man. I feel like if we're gonna talk
Who
about
hasn't played Pac-Man?
Seriously, raise your hand. Anyone?
Crunch.
Alright, we
I'm
got
not
a
a big
few
fan.
games.
You're not a fan of Pac-Man?
I don't know, I just don't like it. It's not fun.
We're
Not for
very
me.
democratic.
What?
Walk, 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 walk.
Because apparently it's already democratic.
I feel like if we're gonna talk about another game, I'd really like to look up some stuff about the history of
I don't know if it was a mall. He went and sat around when we were talking. And he's like, well, what are they interested in? And you're shopping. He's like, oh, very interested. And then actually, he's like, oh, no. Eating. So, that's the inspiration of Pac-Man was saying it was about that.
No, I kind of want to talk about the game, like, the group game analysis idea, or at least the problem. I feel like every time we do it, it's never good. There's always something that I don't know. What?
I said flame war.
Way more. It's always your fault.
My fault.
Exclusively.
I do like flame wars, but I don't see how this.
I'm not sure, but I feel like it could be more productive. I figured maybe we could try giving analysis presentations. Like someone does an analysis on a game and they just present what they found, or at least what they thought was interesting about it. Should I turn on mine?
Oh, I don't know. Dear God. I don't want to do this. You see these? Like, these are maps.
Forever alone. The world's biggest Pac-Man.
Oh, are you talking about the thing with a bunch of different maps that are all linked together?
Yes.
How many are there up to now?
Doesn't sound like fun.
Nice. There's 2 million dots have been eaten.
Wait, people play like contributing to the same score?
Yeah, I think so. Like by country.
Because that's the only way we can win.
That's cool.
And look, there's a navigator.
Dude, you.
That's not
No,
all
no,
of them.
we're winning. We have 1 billion.
I like that Brazil is second place.
No, that's pretty nice. Are they?
Brazil's pretty big
Yeah.
in terms of gaming. At least it's getting.
I'm surprised that, well, actually I'm not very surprised that there aren't any Southeast Asian countries on there.
Just play for fun.
You mean if you play for Facebook, it won't be for fun?
Nope.
You could just play on some
Playing for-
Those
Playing
are
for
all
a
things.
corporation.
Memorials.
I'm gonna admit I don't really like Pac-Man either.
Maybe because it feels like a very generic
Okay.
game.
It's It's on your tail.
Get
It's,
away from me.
I guess if
Look
you
at all those power pellets.
if you were there when the technology was at its peak and this was like super new,
Right.
maybe it would be novel.
Why do you need all the power pellets? That's
Boogie dance. Get back here.
You're ridiculous. You just killed yourself.
Dylan with the fail strategy.
Get over
I
here.
like winning.
Okay. I don't know. I just don't like Pac-Man.
Ghost Eden.
But why don't we like that?
204,159.
I don't like Pac-Man.
Wow, that's
Too many ghosts. You think that'll give you an indigestion?
Who likes Miss Pac-Man?
What?
Miss Pac-Man?
Oh, Mrs.
What's the
Pac-Man?
difference?
One has a bow.
Oh.
Is it faster or anything?
I don't think it's.
Wasn't the original Pac-Man designed?
Dude, go to Wiki Miss Pac-Man.
Boo.
Whatever.
Like, you're allowed to not like Pac-Man. You're allowed to just
Olivia,
criticism.
Wikipedia Miss Pac-Man.
This isn't Chrome, so there's no. When I use Chrome,
Wait,
there's
is
autocomplete and
this
auto
like-
search.
this is
Yeah, I said this isn't Chrome.
Oh,
I'm gonna go to whatever.
Miss
This is
Pac-Man.
Pac-Man.
Miss.
Oh, it's Miss Pac-Man.
She's an independent woman.
Unauthorized sequel.
With creepy.
So it was basically what
Right.
infringement or no? Was by the same company, right?
New maze designs.
This unauthorized sequel makes it
Wait,
sound.
go down to gameplay and see what changes there are.
The gameplay is largely
Four different
identical.
Some
Most new
differences.
mazes, more panels. I like the original.
Game has 4 mazes that appear in sets of colors.
Oh, they're colors now. Ghost behavior patterns.
Okay.
I guess it must have been more balanced.
Probably. You know, it's a better game. Where was it?
Wasn't there a new
Somewhere.
Pac-Man game that came out
I
recently?
think it was, yeah.
And all
Is
of
it
it.
up?
Was it here
I think
somewhere?
so. No. Yeah, stop. It was a
Galaga.
way better game. Do you not?
No, I like Galaga.
Okay.
Speaking of games like this, Life Force.
Hmm?
Have you ever played Life Force?
Life Force? No.
It's like 6 levels long, and it's just super crazy.
You're saying Light Force?
Life Force. Where, I like at one point you fight, I don't even understand it. Like, it seems like you're in space, but then you're at a pyramid. And then you're like, then I think you're in red, like you're fighting against blood cells. And you're just all over the place, and it's amazing. And it's really, really hard. Like at one point you're in between, you have a lava lake below you and a lava lake above you. And things are erupting from both sides.
Sounds
Yeah,
cool.
it was by Konami, so you really needed the Konami code. Until you got good, then it was amazing.
Salamander. It's called Salamander.
Oh yeah.
Like, yeah, in Japanese.
So the
It was retitled for North
localization
America.
decision.
Because
Yeah.
South Magic was.
This game is nowhere, but I played it at my
I
dentist's
love those
office.
old school box art things and the.
Oh yeah. Like Kadash. No one's like ever heard of that game, but it was awesome. It was called like Kadash or something like that. It was ridiculous.
I can't even remember the name of one of the games I thought was really awesome. It was where you, basically the game starts with you getting cursed by some sort of wizard and now you're a ball of clay. Ball of blue clay. That can change into various other things.
So
throughout
you
the
used
game.
to be a person?
That sounds cool.
Or
Sounds
you
like
used to be a
Kirby
ball of
1.
clay?
What?
Did you used to be a person or did you used to be an inanimate ball of clay?
No. You used to be a person. And then all of a sudden now you're a ball of clay. And then throughout, you get to turn into various things. Like at one point there's a water level and you get to turn into, like you get to be molded into a duck.
That's a really weird choice that I see a lot. Like you're this really unique gameplay mechanic, but then they try to tie it with the real world for some reason. You used to be normal, but now you're this. I'm like, why? Why don't you just throw me into this fantasy world?
Well, you ever hear, you know what Bomberman was, right?
No.
Bomberman is what is it?
Terrorism.
Kid Adventure, the Adventure Islands?
Dear God.
No. You know Bomberman? Did you know?
Bomberman?
Bomberman? Like, he was originally the main character from, like, they tied it to one of their other games. I think Adventure Island was it was called. He was actually that person, but he was cursed at one point. And you have to, like, escape the labyrinth, and then all of a sudden, oh, look, you're not Bomberman anymore. You're actually back to whoever you were before.
That's just product placement.
The original MSX game had no real storyline for Bomberman. The NES and Game Boy versions began with Bomberman going bored of making bombs in an underground factory. Under a rumor that robots reaching the surface become human, he decides to escape. Is that what you're talking about? You guys get out of the maze to escape to the surface to become human?
Like, that might be it.
It just doesn't make any sense. So do you want to talk more about
Oh, I
why
like
Pac-Man
that.
isn't fun? Or
We can talk about why
I'm kind of confused.
The other Bomberman
because
is only an enemy due to a programming error that causes it to try to bomb you. The Black Bomberman is an enemy due to a programming error.
and they just left it in there or what? They didn't
Yeah.
notice.
Yeah.
Well, they turn them on. You know how hard you have to but you have a programming error in the robot. You have to basically tackle the robot somehow to sever the power supply. You guys should watch the video. It's called "Don't Solve It in Software."
Don't solve it in software.
Was that the one that we watched at the IEEE that one day
Were you there?
before game night?
Was that the lecture where the lady was drunk?
Yeah, she's
Yeah.
down.
Yeah.
Okay.
What's it called?
Don't solve it in software. And know that all titles are usually hyperbole because
Yeah.
you gotta get a point across. So it means it really means just it's a DEFCON talk. I think it was DEFCON.
Yeah.
Yeah, it was a DEFCON
Yeah.
talk. What it means is seriously consider whether or not it's actually possible to solve it in software before you
Don't
decide.
fix it in software. DEFCON 19. Don't fix it in software.
That might be it, yeah. And it's
Didn't show all the vodkas offered to our gave and prompt two times.
That's definitely it.
yeah. You know what? The reason why she gave a talk that DEFCON is the year before she berated someone for saying that they'll fix it in software, and she was super drunk. And the security brought her aside and said, "Hey, next year you want to do a talk."
Awesome.
Security asked her to do a talk? What?
Obviously,
Why would they
this
do
is
that?
a secondhand story of a secondhand story, so.
Okay. What time is it?
5:51.
10 minutes.
We've got one.
What are we doing next week? Who wants to talk? You want us to talk about Resident Evil
No, I was thinking more of
next week?
English.
English?
Yes.
Wait, what? You want to talk about English?
The people.
No.
English. There's a.
That'll be pretty cool having a mysterious talk that no one knows what it's about. It's just
About English.
Just popped in my head.
Writing in games, I don't know.
Yeah, maybe.
Or you are error.
You gave us like storytelling games.
Yeah.
It's really interesting.
It sounds like something.
Dear Esther.
Yeah.
Has anyone played Dear Esther?
I
Oh,
played
working on it.
I played it at the IGF pavilion at GDC.
Sweet.
It was cool. Although I'm kind of getting tired of those kinds of games because I played so many of them.
What is it? Is it a text adventure game? What?
No, it's just you walk around and you interact with this world and that's it. It's not really a game. You just explore and it tries to be immersive and it tries to. I think I heard that the person who made it or the person who designed it made it in order to explore how far can you take the first person camera mechanic and how deep of an experience can you make using that.
Yeah, that's exactly what happened. Because I went to the talk that they were giving on Dear Esther. That's pretty much what they wanted to do. They wanted like no bells and whistles. All you have is a camera and the narrator.
It was pretty impressive though, with all that.
It's an
It won a bunch of stuff.
So
From the video, the gameplay thing.
Although I still
That's
haven't
really
bought
great.
it and I'm not sure if that said
Yeah,
anything.
no.
I haven't felt I have not been compelled to buy it, and that probably says something. Maybe I'm just cheap.
That could be.
That happens a lot.
Whatever. I have a fun AI related challenge. It's
Okay.
not really a challenge though.
Okay.
So,
Is it critics?
so as I was talking about like how incredibly massive that table would be for like a video game if you were running around on a floating point grid, this is tic-tac-toe. Someone go.
Middle.
Zero.
No, not middle.
Oh,
Not middle. To the right.
Or-
Middle right.
this?
Yeah.
You just lost.
Cool.
So, tic-tac-toe is really easy to solve.
Yeah.
Yeah, middle.
No.
Middle.
No.
There's a way to counter it.
I don't want to keep going on this, so. Alright.
Right. I don't even remember.
That's how I play with children.
You put it to
X,
the top.
you go either on the bottom.
Right. Oh, I got it. Now I do this.
Possible to.
O goes in the middle, obvious.
Sure.
Not that one. Whatever floats your boat.
All right.
Like in between those two. And then X goes in the middle, and then
They
O
can't do
goes-
anything. Yeah. No. So that's kind of a way to look at that. So this is just a game where squares are like completely erased from the possibilities once you like move in them. So it closes down pretty fast in the possible games that can outcome from that. So yeah, and chess. So I mean, okay, so this is solvable. You
How
can.
many possible games are there? How many possible games are there?
I don't care. Technically, if you flip it, there's
Yeah.
only like a fourth of however many. But
Yeah, excluding rotations or reflections.
right. Yeah. So I'll just go over like a basic tactic. So if you're gonna go first, go in the corner or the middle, just in general. If you go in the corner, there's only one square they can move in and still win. But if you go in the middle, there's 4 squares. So like, if you go in the middle, the probability of still being able to possibly survive is 1/2. Whereas if you go here and they were randomly choosing, the probability would be an 1/8, which is considerably better. So going on the side is usually a good idea. But yeah, I mean, I can walk through them like how you can win, how you win. But it's generally a thing of like, you just look at the options and see what you can possibly do and like how to-
26,830.
Right, but there's only so many where you will win.
That's excluding the reflections. and
Right.
rotations.
After the first 4 moves, you know exactly how the game is gonna go. Or no, 2 moves, you know exactly how the game is gonna go, unless your opponent is retarded. That's why you should never play
And
tic-tac-toe.
unlucky. And unlucky.
Yeah,
Never play tic-tac-toe.
yeah, that's why you should never play
Is that
tic-tac-toe.
like the plague, we should avoid it?
Because it's not even like a play thing. It would be a thing that I'd be like, want to play tic-tac-toe? And the
Yeah.
other person would be like, do you? And I'd be like, if you know what I know. And they're like, all right, we don't have to play. We know.
That's why I just play rock, paper, scissors.
This is why, board games, the only winning move is not to play.
Right, right. So, yeah, anyway. So, I mean, there's that. It's a grid of 9 squares. How many squares are in checkers? Like 64?
Yeah.
That's huge. And checkers was just solved. Like you can now play checkers without
Technically, when you said 32 squares, half the squares are 64.
oh right. Well, anyway, checkers has been solved. So you can play a game of checkers where you're guaranteed not to lose.
Nice.
And I'm willing to bet you can do it with like pretty much everything else. Like you can do that with chess. They just don't know that yet. Like that's one of the reasons that whole like looking ahead strategy, that goal-based, that goal-oriented design is really important, is because in chess, the number of possible game states is larger than the atoms in the known universe. Than the number of atoms in the known universe, there are more states in chess. Like it's insane. There's no way we can record all of those. So the only
A lot of them are really bad though.
Hmm?
There's a lot
It-
of bad states.
right. So that's one way we can get around doing that, is we look at that state and we say, that state's stupid. Let's cut off that branch and go to these other states, because we know that's not gonna happen. So no, seriously, one of okay, so they're kind of
Had a computer that won against a human in chess?
yeah,
I mean,
but that's how they do it. Is they look a couple steps ahead. They can't calculate all of them at once and just look it up because that would be insane. But so I don't want to get too much into CS with this.
Also, it used a lot of probability.
Right, right.
So, like, they
So-
beat the best player.
Yeah,
But
but.
then the
That's-
second best player could just completely destroy it. And also,
Yeah.
the best player refused to take advantage of a flaw they had because he didn't really think it was a flaw at the time. And then he
Right.
looked back and he's like, damn it, I could have taken advantage of this flaw.
Also, I heard that the best player said that he did not have the opportunity to study the computer's previous opponents and learn how the
Right.
computer learned, whereas the computer
Had
had
access.
access
Exactly.
to all of his previous opponents and knew his strategies.
So that's
it's kind of an unfair
that is
strategy.
another heuristic, is that you can look at how they play as opposed to how the chess game should go.
Yeah, there's a parlor trick.
And they refused a rematch.
Yeah.
Rematch, and also
Which is a little.
they were allowed to reprogram it between rounds. Was it best 2 of 3? Something
I don't
like
know.
Yeah.
That's really lame.
that? So,
But-
there was still a lot of humanness. around
Right.
there.
So one of the kind of ideas behind this is like, so you take that tree and you start out with your move, and then you're like, okay, so my move, I chose X, and then what are the possible moves that my opponent can make? Well, there's a billion of them, and by billion I mean 8. But if we look at that and we're like, there are different kinds of traversals of this game state tree that we can look at. So in this case, what we might do is if we knew our opponent was intelligent, we would look at that and say, okay, our opponent's smart. There's only one square where he can win, so he's going to choose that square. So we just cut off all of these other branches and we only have one left. And so that's kind of a helpful way to do that. It's like you look into the future and you like predict what your opponent is going to do based on like what you think of them. Yeah.
Yeah, you assume they make the best decision.
Right.
Then explore only.
Right. So this is actually faulty if they make a bad decision
Yeah.
and then come around and do a good one, because then you'll be like, wait a minute,
Yeah, so
your algorithm will mess up.
But technically, they did make a decision here. Yeah. But in case of Tic Tac Toe, there's no way for them to come around.
So is that similar to how
Well, there is.
people?
If they're like not paying attention, so if like, and then X is like, and I was like, cool, and then X is like, that kind of thing. Like that's possible. That's why I'm not excluding it. That's why it's impossible to lose if you know what you're doing.
Yeah.
But you can always tie if you know what you're doing, even if they go first. It doesn't matter.
It's a public ID space. So what do you
What is this? You have to talk to
I have no idea. I'm not on the listserv. What?
I've tried contacting ACM. If anyone in there would be interested in joining our IGF team.
They do have a listserv, right?
I sent it to their listserv and I posted it on Google Plus, thinking maybe they thought to see it eventually. No one, not a single response or comment or anything.
Nice.
It's like,
I wonder. I'm not sure if I'm on the ACM list, so I haven't been able to see it.
end up having assignments that.
yeah, they had even put it on our So like the question
So
of.
you know the transfer thing?
What are the questions?
There's a new access and they misentered it. They got a 5 grade system over there. Kind of like a 5 grade system. And so a 3 which should count as a C, maybe it should be a D. So I didn't get credit for it. Yeah. So I have to go argue with the system tomorrow.
Wait, a D? A C?
Three is a B.
5-minute
2 is a B.
explanation.
Or no, sorry. 5 is an A, 4 is a B, 3 is a C, 2 is a D.
Here?
No, in your
Right.
Yeah, 3 is a C. It's a pass.
Right.
And then 4 is a B. And so
Oh, so you got a-
I got a 3.
I got a